Technical Graphics Higher Level 2018, Section A, Short Questions. Section A, answer any 10 questions. All questions carry equal marks. For the purpose of practice, we will answer all questions. Question 1. Fill in the label for each diagram by selecting from the given list. So, in this question we have a series of different diagrams of different shapes. And we have a list: trapezoid, octagon, hexagon and parallelogram to choose from for each of these figures. So the first one here, we're looking at a polygon that has 6 sides. And a 6-sided figure is referred to as a hexagon. In this figure here, we have the top and bottom parallel, and this side is parallel to this side. So that's a parallelogram. In this one, we have a polygon that has 8 sides. So it's an octagon. And then finally, the last one is what we refer to as a trapezoid. So the correct order there for filling in the names is hexagon, parallelogram, octagon, trapezoid. Question 2. The figure shows the incomplete perspective drawing of a gymnastics pommel horse. A 3D graphic is also shown. Complete the perspective drawing. So, looking at this question, the first thing that we've done here is that all of these lines are brought off to the vanishing points, lightly. So these 2 sides here, or these 2 points, I have projected over to VP2. I've extended all the lines running in that direction over to VP2. And all the lines going in this direction converge on VP1. So this corner here converge onto VP1. So the first thing that we do is we extend all of the important lines and points, extend them back to the vanishing points. So once you've brought those lines off to the vanishing points, we can then begin to heavy in the top. So if we extend that line over to here, we have this corner which is formed by that perspective line going back to VP1. That gives us the corner here which we drop down, and it will also give us this back corner here as this line that goes to VP2 crosses with this line going to VP1, and that completes the top of the pommel horse. Now, we have a point down here that we need to find in order to join it up to this point here in order to complete the perspective drawing. And if we move over here, we can see how that point is obtained. That this external corner that we look at here, so if we bring that corner up and extend this corner back, that gives us this corner here. And if we draw that line going back to VP2, as that meets with the top line coming over here, where those 2 lines meet, we drop down a line then to locate that corner there. So to locate this corner here, the top line is extended back until it intersects this line coming over from this corner. And where those lines intersect, we drop down a vertical line to locate this point on this line going to VP2. And all of that information is given to us in this view here. It is very important that you carefully look at this 3D graphic down here, because there is a huge amount of information there that will help you solve this particular question. So in order to locate that point, we extend out that line until it cuts this top line, drop it down, and that gives us that corner, which we now join back up to here. Then we can heavy in these lines going back into this line. Now, in the question, there's a small gap here. It is very, very important that you make sure that you heavy in all lines, because if you fail to heavy in that line there, it will result in a loss of marks. So there is the completed drawing, the perspective of the pommel horse. Again, got by bringing all the lines over to the vanishing points and then carefully using the 3D graphic to get the information you require to locate this point. Question 3. The figure shows the outline of a mathematical symbol. Write down the measurements of the angles marked A, B and C. So working out A, first of all, we can see that A is part of a triangle. And if we look at the angles already indicated, we have 80 and 50. Now we all know that if we add all the angles of a triangle together, we get 180 degrees. So we have 50 and we have 80 there already. Add them together and we get 130. Subtract 130 from 180 and that will give us angle A. So A is 50 degrees. 130 from 180 gives us 50 degrees, which makes this triangle here an isosceles triangle because the base angles are equal. Now we have A, which is 50, we have this angle here which is 60, and we want to get angle B. A plus the 60 degree angle and B are on a straight line, and on a straight angle you have 180 degrees. So A is 50 and 60 degrees. Adding those two together gives us 110. Subtract 110 away from 180, the number of degrees in a straight angle, and that leaves us with 70. So B is 70 degrees. And if we take the combined angle here, 50 and 60, this angle is alternate to this angle up here. So the combined measure of 50 and 60 giving us 110, angle C is 110 degrees. So the first one there, 50, is worked out on adding the two of those and taking them away from 180 degrees, the number of degrees in a triangle. Then once we have A, we add it to 60 and take it away from 180, the number of degrees in a straight angle. And then we take this figure here. This figure is alternate to this angle here. So A and 60 is 110, making C 110 degrees. That completes question 3. Question 4. The elevation and end view of a barbecue are shown on the square grid. Make a freehand pictorial sketch of the barbecue. Color or shade the sketch. Now again, if there is any evidence of drawing equipment being used in this question, it will be marked from 6 instead of 12. So it is important to remember to draw it freehand. Now, if we move over to our grid here and if we just count the legs, the height of the legs, we have 1, 2, 3, 4, 5 to bring us up to this surface here. So when we move over and we count the dots starting here at the bottom, we have 1, 2, 3, 4 and 5 brings us up here to the top. Now there is an overhang of 2 and you can see that there. So once we have the thickness of that leg, we measure out 2, and then the space in between here is also 5, so we count over 5 and then we drop down 5 because those legs will be the same height. And after that then it's just it's a case of bringing these lines back, following those dots to reproduce the figure of the barbecue. The sloping surface up here, you can see it's back 2 and up 2. So if we want to get that line from this corner here, we go back 2 and up 2, and from this corner here you go back 2 and up 2, and then connect those lines together. So not a particularly difficult question just to get that shape out of it. Don't forget to put in the internal detail there of the thickness of the legs going back, and that then completes the sketch of the barbecue. So using the measurements here of just counting the dots and then applying that over here, produce the pictorial, the 3-dimensional view using the information from the orthographic views on the left. When applying shade to the drawing, I have assumed that the light is coming in from this direction here, which means this surface is getting light, whereas these surfaces here are in shadow and shade. So these are coloured in dark green, the internal detail here of the legs, this area here and this surface here. Whereas the front surface here is in brightness, so it's a lighter colour. Likewise, this is coloured light and this here is a dark colour. So When you're applying colour and shade to a drawing to improve its appearance, assume a direction of light, think about what's going to be in brightness and what's going to be in shade, and colour accordingly. That completes question 4. Question 5. The surface area of road markings similar to that shown in the 3D graphic is specified by law. The figure shows the triangular outline ABC of a directional road marking. Convert the triangle ABC to a rectangle of equal area. Now, to get the area of a triangle, how it is calculated is it's a case of taking half of the base and multiplying it by the perpendicular height. Or alternatively, we can take half the perpendicular height and multiply it by the base, and that will give us the area of the triangle. And knowing that formula gives you the clue that you need to solve this. If we draw in the perpendicular height from B down to AC, and then bisect that height, so putting the point of your compass there and swinging an arc and swinging an arc, and point of the compass on B and swing an arc and swing an arc, and then we draw in the bisector along the top. All we have to do then is join A up to that line and C up to that line. And what we've done now is we've created a rectangle, but that rectangle has half the height of the triangle. Now that rectangle has the same area as the triangle, and we can prove this in the following way. The area of a rectangle is the length multiplied by the width. So if we take this distance here and multiply it by this distance here, we will get the area of the rectangle. And the area of a triangle is half of the perpendicular height multiplied by the base. So that is going to give us exactly the same figure, because if we half that height, it brings us to the same height as the rectangle multiplied by AC, and it will give us the same figure. And also, if we look at this here, you can see that this small triangle here has been added onto this area here, and this triangle here has been added onto this area here. So to convert a triangle into a rectangle of equal area, draw a perpendicular line from the top of the triangle down, bisect that, and then that becomes the top of the rectangle. Using the same base then, bring up vertical lines to complete the rectangle, and you have now converted the triangle ABC into a rectangle of equal area. So that completes question 5. Question 6. The figure shows the elevation of a gavel and block as used by a judge in court. Also shown is a 3D graphic of the gavel and block. Rotate the gavel ABC about the point O until it reaches the top surface LL1 of the block. So here we have the gavel, there we have point O, and here's the block LL1. And what we want to do is we want to rotate this down until the gavel comes in contact with this surface. So if we put the point of our compass here, and you can see that C and D are going to be on one arc and A and B are going to be on one arc. And the first point that's going to come in contact with the block is D. So we rotate that down, and then that gives us this point here. And we bring down A and B all rotated about O. Now, once you have D in this location here, the distance from D to C will not change. So you take that distance on your compass and we mark C along this arc here. That gives you this line running from D to C. Now, the line AD is coming off that at an angle of 90 degrees. So once you have this line established at 90 degrees, bring a line out here and bring this line out at 90 degrees until it cuts this arc, and then we can heavy in this block here. And then finally, put your compass on D, take the distance to that point there, the halfway point, mark that there and join it back to O, and that completes that drawing. So that's question 6, rotations. Question 7. The figure shows the elevation and plan of a lectern. A 3D graphic of the lectern is also shown. Project an auxiliary elevation of the lectern on the line x1, y1 to show the true shape of surface S. So when we look at this drawing, we can see surface S in elevation, and here is surface S in plan. So we project off surface S at an angle of 90 degrees. These projection lines must cut across the x1, y1 line at an angle of 90 degrees. So all principal corners on the lectern are brought up here off surface S at an angle of 90 degrees and cutting across the x1, y1 line at an angle of 90 degrees. To achieve this, first of all, line up your set square with the surface S in plan. Slide the set square out of the way, and using your other set square then and the 90-degree angle, you can slide your set square into those points to bring the lines up at an angle of 90 degrees. Because we are projecting from plan, the view that we will be drawing over here is an auxiliary elevation as stated in the question. Heights do not change in elevation, so the heights that you have in this elevation are the same heights that we will have to apply to the new one. So in this elevation, I've drawn a line out here, and I've taken H1, H2 and H3. Those distances off the XY line, and I have applied them over here in this view off the XY line again, H1, H2 and H3. And this sets up a grid from which I will obtain the auxiliary elevation. So after bringing our points, our projection lines up from plan, and taking our heights from elevation and marking those heights in this elevation here, and then if we look at getting surface S, if we start in this corner, which would be on that line there, the first thing is that it goes all the way up to H3, it falls back to H2 and then goes all the way back down to the XY line again and comes back. Now if we go down to our plan, we can see that surface S is contained from this projection line to this one. So if we follow this line up, we have a line running from the XY line all the way up to H3. Then it falls down to H2 onto this projection line, follow that up. The surface falls back down to H2, and then we bring it all the way back down to the X1, Y1 line. And there is the true shape of surface S. Now, if you were to do no more than this, bring up the lines from the plan, take your heights from elevation and apply the heights to the new elevation, and then concentrate on getting surface S correct. Out of 12 marks, you will be awarded around 8 or 9 marks for that. So there is a significant number of marks for getting what I have completed there. Now the next bit is a little bit challenging. It does require a little bit of visualization, but if we follow this elevation here, whatever the height these points are at in this elevation is exactly the same height that the points will be at in this elevation over here. Very important to remember that. So if we now take this surface here, which represents the bit of the lectern that is sticking out, we can see that the top of it is on H2 and the bottom of it is on H1. And if we look here, it's going to be from this projection line out to this projection line. So when you follow those projection lines up, and if we follow this one up here as well, and bring a line then out from the lectern out there along H2 and this one on H1, that gives us then this surface here, and we see that surface up here in the auxiliary view. Likewise, we have this little bit of a surface, we can see that there. This is the front of the lectern, which is this vertical surface rising up here. And that goes all the way up to H3. So on this side, when we project up that line, we draw a line all the way up here to H3 and connect it back into surface S. Now, every surface that you draw is getting you marks. Now, you may not get all of them out of it, but you need to make an attempt to try and draw as many surfaces as you can. So again, when we look at this one here, we see that we have this area here, which is coming out, which is this part of the lectern in elevation. It's on H2 and it goes down to H1. So we come out on H2, down to H1, and we draw that surface there. And then we have this small little bit of a surface here, which is the front, and that's going all the way up to H3. So we just draw that there and connect it back into the original surface that we drew. So once we've dealt with the surfaces that we can see, which is the front, surface S, and this side here, we then have to consider the surfaces that are not visible to us, which will be this area here, this line coming back, and this one here. But again, the same principles apply. So if we look at this line here, it begins there on H0 and it goes all the way up to H2. So when we follow that line up there, starts at H0, goes all the way up to H2. Then if we look at it, once we get to here, it's joined up here to the top. So then we go back over here, we can see we have a hidden detail line joined from there up to the top. So once we have that then done, right, all we have to do then is complete the hidden detail there for this portion that's sticking out. And to do that then, as this surface comes in that we can see, that's going to give us a dashed line into this corner, because once it goes beyond that corner there, you can't see it anymore, and the same is true for the bottom. Then finally, we have this corner here at the back, and we just bring that up and it gives us this broken line here to represent this corner at the back. So that completes the auxiliary elevation of the lectern, showing the true shape of surface S. Question 8. The elevation and plan of a date stamp are shown. In the space provided, draw a freehand pictorial sketch of the stamp. Colour or shade the completed sketch. So if we look at this, we have a square base, we have a cylinder going up to a cut-off cone. So when we're drawing this, start by drawing a rectangular base. And again, we have lines rising up in this direction and lines rising up in that direction to give us the three-dimensional shape. Very important to keep the lines parallel, as that will preserve the geometry of the stamp. We then, once you have the square base produced and you're happy with how it looks, off that then we're drawing a cylinder. Now as you look at a circle in a pictorial view, this will appear as an elliptical curve, as will this one here. And then up here on the date stamp, you can see there you have an ellipse that's going to be slightly bigger, and then we connect the sides of that down into that cylinder. So once you have the rough shape established and you've sketched that out and you're happy with it, then we can start by refining it and applying the colour and shade. So when applying shade to the drawing, first of all start by just going around the perimeter with a heavy black colouring pencil, as that then just kind of separates the drawing from the sheet and makes it stand out that little bit better. Again, assume your direction of light, and I've assumed that the light is coming in here from the top, so this top surface is getting lit up. This surface here is going to get will be lit up, so it's a lighter colour, and then this surface will be in shade, so it's a darker colour. So again, just try to make a difference there between the surfaces. Now because this is a curved surface here, there's a gradual transition between light and dark. So you can see on this side here, it's been shaded light and then gradually going around and getting darker on this side. And that is the case up here. And then the top surface of the stamp is shaded in light. So just try to have a variation between the degrees of shading that you have on your drawing. Form a good, decent drawing of the stamp, getting the square base correct, the cylinder and the cone. And then when it comes to applying colour, think of a direction of light and then apply appropriate degrees of shading to your drawing. Question 9. Write down any 3 CAD commands used to edit the drawing of the hall mirror as shown in the sequence below. So beginning here, we start off with a vertical and horizontal axis, and then we have this shape here. And this shape, as we know, is referred to as an ellipse, and there's the command. So we use the ellipse command to produce this shape here. The next thing that we're shown is this distance, and these distances are called dimensions. When you put in a measurement there to apply a measurement to a drawing, we refer to those as dimensions. And the command for that in CAD would be dimension, smart dimension. When we move on to the next one, we can see there's a smaller ellipse to the inside of the outer ellipse. And that command to place a smaller one inside here is called offset. So we have offset the pattern from the original pattern to produce this smaller one. And then to turn it into 3 dimensions, the command is extrude boss base. So beginning here, we have ellipse, smart dimensions, offset, extruded boss base. And those are the figures those are the commands that we fill in here. Ellipse, smart dimensions, offset, extrude boss base. That completes question 9. Shown is the outline, elevation and incomplete plan of an Angry Bird character in contact with a sloping block. A 3D graphic is also shown. Draw the plan of the sphere and locate the point of contact between the sphere and the block. So in elevation, we are given the sphere in contact with the block. And a sphere, it doesn't matter what way you look at it, its radius will remain the same. So we drop the center into plan and we get this point here. And then using the same radius that we have in elevation, you draw the circle in plan. Now you have the sphere in plan and elevation. So the next thing we want to do is we want to locate the point of contact. Now we can see that the point of contact is going to be in this region here. Now we have a circle and we have this block, and the side of the block is tangential to the edge of the circle. Now once the whole concept of tangents are mentioned, an angle of 90 degrees should come into mind. So in order to get the point of contact, we draw a line from the center of the circle at 90 degrees to the tangent, or the line here on the block. And that will give us the point of contact here. So lining up this set square with the edge of the block and then sliding out of the way, and then with the 90-degree angle on your other set square, draw a line from the center of the circle at 90 degrees to the block, the side of the block. And then that will give you this area of intersection here, and that is point P. That is the point of contact between the sphere and the block. So very, very simple solution. Line up your set square with this edge using the 90-degree edge of your set square here, or the 90-degree angle. Draw a line from the center of the sphere to the side of the block at an angle of 90 degrees. That will locate the point of contact in elevation. And once you have the point of contact found in elevation, any point in elevation is going to be directly below in plan. So we drop P straight down into the plan onto the center line, and that gives us the point of contact in plan. So a simple enough solution to that question. First of all, we just drop the center of the sphere into plan, and using the same radius that we have in elevation, we draw the sphere in plan. Then we bring a line from the center onto the edge of the block at 90 degrees to locate the point of contact. And then we drop that down into plan to get the point of contact in plan. And that completes question 10, finding the sphere in plan and the point of contact in elevation and plan. Question 11. Figure point 1 shows a logo for a telephone company. The curve ABC is based on a semi-ellipse. Figure 2 shows the location of the axes and the focal points of the semi-ellipse. The point P is a point on the curve. Determine the lengths of the major and minor axes and complete the drawing of the logo. So in this question, we're given the two focal points F1 and F2, and we're also given point P. And the first thing that we do is we join from F1 up to P and back to F2. Now, as you should know, that if we draw a line from F1 to P and back to F2, the combined distances from F1 up to P and P to F2 is equal to the full length of the major axis. So anywhere on the sheet of paper we draw a line and we mark the start of that F1, and you take the distance on your compass from F1 to P and you mark it on this line, and then you take the distance from P to F2 and you mark it along the line. Now that distance then from F1 all the way over to F2 is the full length of the major axis. So we take our compass now and we bisect that line to get the midpoint of the line. So from there out to F1 is half the major axis. We take that distance on our compass from this point to F1, and from the center here of where the minor axis intersects the major axis, I mark that distance out there, and that will give me the end of the major on this side and the end of the major on this side. So in order to get our major axis down here, first of all, we realize that if we add the distance F1 to P and P to F2, all of that adds up to the major axis. So we mark them onto a common line. We bisect that line, and then taking half the length of that line, mark it left and right of the center line here to obtain the major axis. Now if we go over here to this drawing, we can see then that the end of the major axis gives us the base, the end of these rectangles here, forming the earpiece and mouthpiece of the phone. So there's the end of the major. Drop that down and extend over the rectangle to meet, extend over the rectangle so it's in line with the end of the major axis here, and do the same thing on this side, and then we heavy them in. Once we have the full length of the major axis marked, we can then heavy in this line here between the curve and out to the end of the major axis, complete the rectangles here at the bottom. Now we need to find the minor axis. Now we know that if we take half the major axis and put it on top of the minor axis, you can swing an arc to get the focal points. That also works in reverse. So if you take the distance, half the major axis on your compass, put it on F2 and swing an arc up here, that will give you the minor axis, half the minor axis, and you mark that there. So again, half the major axis on your compass, point of the compass on F2, swing an arc to locate the minor axis. So with a scrap piece of paper, and out here at the end of the major axis, mark a point P, take half the major axis and mark that on your piece of paper. Then moving around the piece of paper, that P is on the end of the minor axis, then take half the minor axis and mark it on your piece of paper to make a trammel. So keeping these 2 points here on your trammel on the major and minor axis, and then using P, mark a series of points all the way around. And then when you have all of those points marked, join them together to create the ellipse there going through point P. So that completes question 11. So just to recap again, the first thing that we have to realize is that the distance from F1 to P and back to F2, that's the full length of the major axis. So we mark them onto a line and bisect that line. Then you mark that line either side of the center line to get the full length of the major axis in position. Once you have that done, you have your full length of your major axis. Take half the major axis, put it on one of the focal points, swing an arc to locate the minor axis, then make a trammel or use the concentric circles method, and we produce the ellipse to fill up this space here. Then draw the two rectangles at the bottom, heavy in these lines here to complete the shape. A lot in that question requires a little bit of thought, but if you know your material, you shouldn't have any real problems with that. So that completes question 11. Moving on to question 12. The graphic below shows 3 stacking puzzles. The plan of each puzzle is shown on the right. Match the correct letter with the appropriate puzzle below. So we have the 3D graphics here, and we have the plans over here, and we have to match each of these. Now, if we look here at A, well, you have the large disc on top and you have the 2 other discs directly below that. So if you look at A, you can see the large disc, and then the hidden detail line represents the 2 discs below. So this last one here is A. So moving on then to this one here, we can see then we have it stacked the smallest, the medium down to the large. There's no hidden detail in this because you will be able to see all the discs on those. So therefore C is the correct answer for this one here. Because if you look at C, you can see all of these ones, all of the discs on that, and there's no hidden detail. So C is the correct answer there for 2. And with this one here, we can see the medium disc on top, you have the small circle underneath and then the large one at the bottom. So that gives you that hidden detailed line there. And obviously then the last one is B. So B, C, A is the correct order for question 12. Question 13. The graphics show the design of a door mirror for a car. The centers of the arcs are shown. Show clearly all points of contact. So to get the points of contact between any circles, you connect the center. So beginning here with this one, we have this arc. We have this arc here, which is generated by that center, and we have this arc here, which is generated by this center. So if we join this center to this one, that gives us the point of contact here. We also have this center, and we connect them together to get the point of contact here. Now, down here we have a tangent to the circle. So we bring a line from the center down here at an angle of 90 degrees to get P3 and P4. Now, this is a little bit different in the fact that we have this arc here, this large arc, which is generated by this center, and we have this arc here. And how do we get the points of contact? Well, it's still a case of connecting the centers together. So if we connect this center to this one and then let that line run on, it'll give us the point of contact that we're looking for in these 2 locations. So in order to get the points of contact between circles, the most obvious one is you just connect the centers together, and if you have a point of contact that lies between them, that's how you find it. But if you have 2 centers of a circle and the point of contact is not in between them, if you just extend out the line, it will still give you the point of contact where the 2 arcs meet. And the important thing to remember here is not to forget the points of contact between the tangent and these arcs as well. So by bringing a line from the center onto the line at an angle of 90 degrees, that will give you those 2 points of contact there. So 6 points of contact in all, 2 marks for each point of contact found. Question 14. The graphic shows a digital camera. Draw a well-proportioned freehand sketch of the elevation of the camera viewed in the direction of the arrow. So we have this arrow here looking in the front direction here of the camera, and in this area over here we have to produce what the elevation would look like freehand. Now again, it's important to mention here, any use of drawing equipment in this sketch will result in the question being marked out of 6 instead of 12. So make the effort to draw it freehand. So when we look in this arrow coming in here, we're going to see the main body is a rectangle, which is represented here. We have this side coming down there, which gives us that line there, the mid portion of the camera. You have that sloping surface, which is just going to be a line across there. As we look in at the lens, there's two circles, the inside circle and the outside circle. So we have that indicated here. And we have this area up here with the two sloping sides and the flat top. So two sloping sides and the flat top, and then finally here the button would appear as a rectangle. So that's what the elevation would look like as viewed in the direction of the arrow. No shading was required in that question. And finally, the last question, question 15. 24 tourists were surveyed while visiting a village in Ireland. The following were the nationalities of the tourists surveyed: United Kingdom 12, United States 6, Germany 3 and France 3. Divide the given circle to represent this information graphically as a pie chart. Colour or shade the completed pie chart. So the total number of tourists that visited the village in Ireland was 24. So we have to work out, based on these numbers, the fractions out of 24 that 12, 6, 3 and 3 are going to represent. So 12 from 24 is half. So the United Kingdom, if we draw a line right down the middle of the circle, half of the circle is going to represent the number of tourists that came from the United Kingdom. 6 were from the United States, and 6 out of 24 is a quarter. So we draw a line from here out at an angle of 90 degrees, and that represents the tourists that came from the United States. And then finally, Germany and France were 3 and 3. So we divide this remaining quadrant into two equal parts. So that's a line at 45 degrees, and that represents Germany and France. Colour the pie chart then to present it well, and that completes question 15. That completes the solutions to the 2018 Technical Graphics Higher Level Paper Section A.